This lesson is on properties of parallelograms. Since parallelograms are the most used shapes besides triangles, we're going to spend some time talking about their specific characteristics. Understanding that everything that's a parallelogram has these characteristics. So rectangles, rhombuses, and squares all share these characteristics. Property 1. The opposite sides of a parallelogram are congruent. We know by the definition that the opposite sides are parallel, but this property allows us to also say that the opposite sides have to be congruent. So in a parallelogram, a rhombus, a square, and a rectangle, the sides that sit across from each other are congruent to each other. Property number 2 has to do with the angles. The opposite angles are congruent. Opposite angles are the angles that sit directly across from each other. These arrows show the opposite angles. Angle L is opposite angle N in this parallelogram, and so therefore we would be able to draw arcs on them saying that they are congruent. The same with angle O and angle M, they would have to be congruent to each other. Another property of parallelograms is that consecutive angles are supplementary. Consecutive angles are angles that sit right next to each other. So angle A and angle D would be supplementary, which means they would add up to 180 degrees. So although opposite angles are congruent, the angles that sit right next to each other have to add up to 180 degrees. The third property is about the diagonals. When you draw a diagonal in a parallelogram, it connects opposite angles. The diagonals of a parallelogram bisect each other. That means that they cut each other in half. So what we would know in this picture is that the distance from A to E would have to be the same as the distance from E to C, and the distance from B to E would have to be the same as the distance from E to D. Though that is what we know based on property number 3. The following examples are examples that use those 3 properties that we just talked about. Example 1 gives us a parallelogram, and it gives us that the opposite sides are 2x plus 3 and 3x minus 15. Because of property number 1, we know that opposite sides have to be congruent. Therefore, we would know that 2x plus 3 has to be equal to 3x minus 15. From there, we can do our algebra skills. We would subtract 2 x's over here and make that a 1x, and then we would add 15 over to the other side since it's negative and make it 18. So our x value would be equal to 18. If I wanted to know then what my actual length would be, I would plug 18 back in. 2 times 18 is 36, plus 3 would be 39. And that is how that would go. The next one is talking about our angles. It gives us something about consecutive angles, and it gives us something about opposite angles. It's not going to do me any good to say that 2x plus 12 plus 6y plus 4 equals 180 because they do not have the same variables. Nor is it going to do me any good to connect these two because they have different variables. Instead, what I'd want to do is find the relationship between these two because they have the same variables. Since they are opposite angles, I would say that 3y plus 37 has to be equal to 6y plus 4. And now I do my algebra. I minus 3y over to this side and get 3y. I minus 4 over to this side and I get 33. I would divide by 3 and y would be equal to 11. Okay, so I could plug 11 back in. 6 times 11 is 66. Plus 4, the lengths of, or the measures of these angles would be 70. 3 times 11 is 33, plus 37 is 70. That does not tell me what x is, but it does tell me how much this angle has to measure. If this angle is 70, then this angle has to be whatever's left to get to 180. since consecutive angles are supplementary. So I know that 2x plus 12 has to be equal to whatever's left from 70 to get to 180, so 110. I do my algebra, I minus my 12, and I get that 2x equals 98, and then I divide by 2, and x would be 49. Okay, I already know that the angle has to measure 110, but that tells me then that x is 11, or excuse me, that y is 11 and x is 49. The third example has to do with property number 3, the diagonals of our parallelograms. The diagonals bisect each other. That means that the two halves have to be equal. So I would know that 2a would be equal to a plus 9, which then I would subtract a, and a would be 9. 1a would be 9. I would do the same thing going the other way, that b plus 10 equals 2b minus 8. I would minus b, I would add 8, and b is 18. If I wanted to know what the actual lengths of the segments are, I could easily plug the 9 in for A and the 18 in for B and get the lengths of the sides. The last topic in this lesson has to do with some extra information that doesn't really necessarily fit in with the topics that we just discussed, but nevertheless there are quadrilaterals in here. It has to do with parallel lines. When you have more than one pair of parallel lines cut by transversals, which we talked about in chapter 3, we know that they create angle measures that are congruent and supplementary, but we didn't talk about the segments that they create. When parallel lines are cut by transversals, it creates pairs of segments. And this last piece of information, it's a theorem, and it says if 3 or more parallel lines are cut by a transversal and one of them creates congruent segments, then all of them have to create congruent segments. Therefore, x would have to be the same as this length, so it would have to be 2.6. And y would have to be the same as this length, so it would have to be 2.9. That concludes this lesson. If you're in my class, the homework is as follows.